Hello, pre-calculus students. We're now going to start a unit on trigonometry. And trigonometry is a combination of a bunch of Greek words that means three-angle measure. It comes from the study of triangles, so it can't be that tough, can it? So let's start with angles. So we're going to learn about angles and radian measure. So an angle, you start with a ray. This is the initial side of the angle. You pin that ray at its starting point and you rotate the angle, you rotate the ray. Where you stop is called the terminal side of the angle, and this in here is the measure of how much you rotate it. That is an angle. An angle is said to be in standard position if it's pinned at the origin and is pointed along the positive x-axis. If you rotate the angle through the first quadrant, which is counterclockwise, your angle is considered to be positive. And if you rotate it clockwise down starting through the fourth quadrant, that is a negative angle. Now, some of you are really going to resist this business of radians. You're going to want to convert everything to degrees. Resist this urge. I'm here to tell you that within a couple of weeks, radians will be second nature to you, but you got to give in to it. It's like I tell you, you got to accept fractions. Quit trying to turn everything into a decimal. Same here. Quit trying to turn everything into degrees. I know you're thinking, oh, I'm just trying to understand it. No, what you're actually doing is making it more difficult for you to work with radians. So a radian. There's an angle theta. This is the Greek letter theta. It's a circle with a diameter across it. If you take a radius r on a circle and let this be a ray, and you rotate it such that this arc length here is equal to the radius. So S is arc length. I don't know why we use S. So if this distance here along the circle is equal to this distance here, this angle is 1 radian. And you can see the theta is S divided by R. So this is, S divided by R, or R divided by R would be 1 radian. Normally, when we speak in radians, we speak in terms of pi, because what's the diameter of, the circumference of this circle? It's 2 times pi times R. So how many of these R's are there in the circle? 2 pi. So one circle, a full 360 degrees is 2 pi radians. 180 degrees, so if we just rotate through half a circle, is going to be pi radians, and 90 degrees is pi over 2. Just start trying to accept that and use those terms without trying to convert everything from 360. A right angle is pi over 2. Now if we wanted a 30-degree angle, it would be 1/3 of this, which would be pi over 6. A 45-degree angle would be half of this, would be pi over 4. When you can also think that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. It works that way. And of course, 2/3 of this would be 60 degrees, or pi over 3. 0 and 2 pi, just like 0 degrees and 360 degrees, are coterminal. We're going to define that in a little bit. Use a little algebra here to convert degrees to radians. 180 degrees is pi radians. Divide both sides by 180 degrees. Or you can multiply by the reciprocal of this to get from degrees to radians. Now, as I said, an angle theta is measured in radians. Radians don't really have units because think of it as arc length divided by radius. Those are both lengths. A length divided by a length is a ratio. The units cancel. So there's no units to speak of. Radians are really a ratio. So if F equals R times theta, theta, the angle, equals S over R, multiply both sides by R. This is a formula. Arc length equals the radius times the angle in radians. If we have a 30-degree angle here and a radius of 3 centimeters, how long is this arc length? Well, if you go 3 centimeters times 30 degrees, centimeters times degrees, that's a mess. Nobody knows what that is. But if you remember, pi over 6 has, we call it radians because you got to call it something, but it has no units. So if you take 3 centimeters and just multiply it by this fraction, this proportion, you get pi over 2 centimeters, which is approximately 1.57 centimeters. And if you look at the drawing, if that's 3 and that's 30 degrees, that should be about 1.57 centimeters. So this formula only works when theta is in radians. The area of a sector. A sector is the pi piece of pi. So if we think of it as the area of the sector divided by the area of the circle is equal to the angle divided by 2 pi. In other words, we're setting up a proportion. Then you could solve for the area of the sector by multiplying both sides by the area of the circle, which is pi r squared. So you have theta over 2 pi times pi r squared, the pi's cancel, 1/2 r squared theta. Again, theta has to be in radians for this formula to work. And here's a little tidbit of history. The ancient Babylonians go back thousands of years. We're still using some of their math. It's weird. The Babylonians didn't use a base 10 system like we did. They use a base 60. Everything was divided up into 60. So even today, 1 hour is 60 minutes. 1 minute is 60 seconds. And we use that same notation, 1 ticky mark for minutes and 2 ticky marks for seconds. We divide degrees the same way. 1 degree is 60 minutes and 1 minute is 60 seconds. So you can see there are 3,600 seconds in 1 degree. Yeah, and the Babylonians did that. They were measuring the stars and stuff. Their astronomy and their math were both pretty impressive, such that they were dividing a degree into 3,600 units. So let's convert decimal degrees to degrees, minutes, and seconds. Where do we see degrees, minutes, and seconds? You often see it on GPS. Sometimes you can set a GPS for decimal degrees. Sometimes you can set it for degrees, minutes, and seconds. So let's say we are measuring something and it's 46.371 degrees. Well, it's got to be 46 degrees and something. So we take off the 46 degrees and we're left with 0.371 degrees. Well, there is 60 minutes to a degree. So I'm doing some dimensional analysis here. The degrees will cancel. 370 or 0.371 degrees time is 22.26 minutes. Well, it's got to be 22 minutes. So you're left with the 0.26 minutes. 0.26 times 60, 15.6 seconds. So 46.371 degrees is 46 degrees, 22 minutes, 15.6 seconds. This is a little bit bigger than 1/3 of a degree. 1/3 of a degree would be 20 minutes. Just think of a degree as an hour, and this stuff will make sense. So this has got to be a little bigger than 20 minutes, and it is. When you go backwards, though, from degrees, minutes, and seconds to decimal degrees, you got your 46 degrees, 22 minutes is 22/60ths of a degree. Some people want to divide this by 60, but that would only get you minutes. You have to divide by 3,600 because we have to convert 15.6 minutes or seconds into degrees. So we divide the minutes by 60, the seconds by 3,600, and we're right back to where we started. So that's our introduction to radian measure. Let's talk a little bit more now about angles in general. Coterminal angles. Let's say we put our angle in standard position, pinned at the origin, pointing in the positive x-axis, and we rotate it counterclockwise 30 degrees, or pi/6. Well, if you then went another 330 degrees, let's try this again. 360 degrees is an entire circle. So if we started it here and then went another 360, you'd see we'd be at 390. But the terminal side would be in exactly the same place. Okay, they overlap. Such angles are called coterminal. Co means with, terminal means ending, so with ending. They're ending with each other. I had a student once who described these coterminal angles was kind of like synonyms. That's really a good, interesting, unique way of looking at it. So this angle theta with 30 degrees is theta, any angle plus 360 degrees times a k, integer value k, will get you a coterminal angle. And we could also do 2 pi k, because 2 pi is an entire circle if we're measured in radians. Now we could also get a coterminal angle by going minus, you go 330 minus 360, so our angle could be considered a negative 330 degree angle. So what's one more positive coterminal angle for 30 degrees? I've already given you 390. What's one more positive one? And I've already given you negative 330 degrees. What's one more negative one? Alrighty. So can you come up with one more positive coterminal angle and one more negative? Well, a positive one would be 390 plus 360 degrees. What's that, 750 degrees? And if you go negative 330 and then go another 360 degrees in the negative direction, negative 360, that would be negative 690 degrees. Quick review here, degrees, minutes, and seconds to decimal degrees. We know the degrees is going to stay the same. Convert the minutes to degrees, convert the seconds to degrees. Add them all up and you get your decimal degrees. Go decimal degrees to degrees, minutes, seconds. We know it's going to be 65 degrees, so we're left with 0.384 degrees. Multiply that by 60 to get minutes, and that gives you 23.04 minutes. You know that's going to be 23 minutes and change. So now convert that 0.04 minutes to seconds by multiplying by 60. That gives you 2.4 seconds. So we end up with 65 degrees, 23 minutes, 2.4 seconds. Right, now there is such a thing as angular velocity. Angular velocity is, how much angle do you go through per unit time, degrees per second or radians per second or something like that. If a merry-go-round is going around 30 revolutions per minute, that's 2 seconds per revolution. So our angular velocity, it goes 2 pi radians, which is 1 revolution, in 2 seconds. is pi radians per second, which is equivalent to 180 degrees. So it's going around a half a time every second. That's an angular velocity. So omega, this little W looking thing, but it's all curved, omega is equal to theta over t, your angle divided by time. Linear velocity, I had these two reversed. Linear velocity is arc length divided by t. Linear velocity is what we normally think of. How fast are you going? Somebody sitting here on the merry-go-round is only going through this distance, this circumference, every 2 seconds. Somebody sitting out here would be going this circumference. You can see it's twice as far in 2 seconds. So linear velocity is arc length divided by time, or the arc length is velocity times time, d equals rt, just what you're always used to. So that's it for this lesson. I'm sure the introduction of radian measure is going to be a little bit uncomfortable for a bit, but trust me, in a week or two, it'll be second nature to you. I've been doing this a long time. I know this stuff. You will get it. Just don't resist. Don't try to convert everything to degrees. Kind of like when you learn a new language, jump right in. That's all I've got for now. Have a great day. And somewhere, oh, there it is. Now, have a great day.